Hello and welcome to Pre-Calculus Lesson 3. Today we're going to be covering the Pythagorean theorem, which you should already know, then a bunch of weird Pythagorean theorems that you've never seen before, similar polygons and similar triangles. So let's get started with the easy one, the Pythagorean theorem. So you remember that number one, it only works, let's see if I can write something, nope. It's really hard to write something and say something else. It's like the same part of the brain does both. Okay, so the Pythagorean theorem only works for right triangles. So if you don't have a right angle in your triangle, you can't use it. It also says that if sides A, B, and C are like that, a squared plus b squared equals c squared. If that's not on your equation list already from 5th grade, please add it there now. Sorry, that was a little too close to home. Anyways, C is always the hypotenuse or the longest side. The easiest way to find the hypotenuse is to look opposite the right angle. So with that, you may be surprised to find out that there are two other forms called triangle inequalities. So we can figure out we can classify a triangle based on how a squared plus b squared compares to c squared. Now, that sounds a little bit weird. Let me quantify that. If a squared plus b squared is equal to c squared, I know that I have a right triangle. But what about an acute triangle? What about an obtuse triangle? Well, you'd be surprised to find out, actually, that for an acute triangle, a squared plus b squared is greater than c squared. And for an obtuse triangle, a squared plus b squared is less than c squared. Okay? So if you test a squared plus b squared and compare it to c squared, you can actually figure out what type of triangle you have. Let's do an example. I'm getting x. Oh wait, we don't have an x out here. Never mind. So the lengths of the sides of a triangle are 7, 5, and 4 respectively. Is the triangle a right triangle, acute, or obtuse? So our first step is to find the longest side. That's going to be C, and the other two really don't matter. So what I'm going to do is I'm going to compare a squared plus b squared and c squared. I'm not going to put a symbol here because I really don't know. So maybe a question mark. Okay? A and B really don't matter the order. I always go from smallest to largest so I don't mess it up, because you can accidentally put the 7 over here and then it really does mess up everything you're doing. So 4 squared plus 5 squared, question mark, 7 squared. We don't know yet if it's equal, less than, or greater than. So I'm just going to put a question mark. 4 squared is 16, 5 squared is 25. We're skipping steps here, so it's 30, 41. Question mark, 49. Well, 41 is less than 49. So that means I have an obtuse triangle. Let's check our work in the book. Oh, that's right. So your answer is that the triangle is obtuse, okay? Because a squared plus b squared was less than c squared. Pretty nifty trick. You can use it as a cool party trick in real life. How often are you going to use it? Well, maybe not, but it's always nice as mathematicians to have a couple of cool party tricks in our back pocket. All right, similar polygons. So the requirement for polygons to be similar is as follows. All angles in a polygon, or in two polygons, must be congruent and in the same order. So for this shape, as an example, I did not draw that shape correctly. I tell you that this is angle 1, and that's the same. This is angle 2, and that's the same. This is angle 3, and that's the same. We can infer that no, actually, we shan't. Let's try an angle 4, just because. So, we could actually infer that the fourth one is the same. But the idea is that angle 1, then it's angle 2, then it's angle 3, then it's angle 4, in the same order. The shapes are oriented in the same way. These two are similar. You can always rotate a shape, but eventually you should be able to get them to be identical in the way that their angles are laid out. Once they're similar, then I can do the same as I did back in algebra with similar triangles. So let's put some numbers on here. 4, 3, 2, 5, 10, 8, x, y. So could I solve for x or y here? Absolutely. All I have to do is pick a pair that does have both numbers. So 4 divided by 8 equals, and then I want to pick the corresponding side to the other one. So 3 over x. Cross multiplying, 4x equals 24, x equals 8. Is that right? 8 times 3, 8, 16, 24. 24 divided by 4 is 6. Yep, that's what I wanted. If I wanted to find y, I could still do 4 over 8. Sorry, a little brain fart there. Equals, I'm going to use this corresponding side, 2 over y, because these are in the same spot between angle 3 and 4. Between 3 and 4 is y. So y equals 4. Okay? So that's similar shapes, and obviously similar triangles are going to be quite similar, except now you're in pre-calc. So everything's harder. So I know I said that you could skip steps. I'm saying skip the algebra steps, but here in this problem, you're going to be tempted to skip the first step that I require you to do. So please don't do it. Don't skip this step. Okay, in this case, we have this angle as the same, and this angle as the same. Since it's a triangle, we know that the third angle is the same, but it's not given to us. We have 4, 5, x, 7, 6, y. Now, these two are similar triangles because all the angles in the two polygons, or the triangles, are congruent. They have the same measurement. Since we have 2, we know the third one is the same. But are they in the same order? Well, if they are, then I should be able to rotate this so it matches that. Sometimes I have to flip it, okay? And so the first step is I want you to redraw the triangles. But I want you to redraw them so that they're pointing the same direction. This is required. So I'm going to keep the left one as is. I have angle 1 here, angle 2 there, and angle 3 here, 5, 4, and x. But now I'm going to redraw this one so that it matches that. Angle 1 is here, angle 2 is here, and angle 3 is here. What does that mean? Well, it really means that I had to flip it that way. Let's see. I think I just rotated. I go whoa. So if you rotate this way, then you get this shape. So the reason why I'm having you redraw it is because oftentimes here students will mess up in saying what sides are similar. Like 5 and 6, for example, look like they're similar, but actually 5 is between angle 1 and 2, and 6 is between 1 and 3. So they're not the similar sides. They're not the corresponding sides. So that's why we rewrite it. So how do I redraw this triangle in this direction? This is how. I'm going to look between angle 1 and 2. Between 1 and 2 here, it's 7. So that means this is 7. Between angle 1, angle 2, my side is 7. Between angle 1 and angle 2, my side is 7. No, it's a little freaky. Between angle 1 and 3, this side is 6. between 2 and 3, it's y. Now that they're pointing the same direction, I can do the same thing I did over there and just do the ratios. So I want to pick the pair that has both numbers, so 5 over 7. I always do left divided by right. Some of you guys do 5 over x equals 7 over 6. I don't like that for whatever reason, so I do 5 over 7 is x over 6. Since I've drawn it out this way, I can see what sides go with what sides. If you skip this step, you will lose a lot of points, even if you get it right. So x is 30 over 7. Now let's do the same thing for y. You can barely see that. There we go. For y, I'm still going to use that same pair that I know, 5 over 7 equals 4 over y. Always do left to right, and you will get it right every time. Maybe not. Maybe you'll still get it wrong, but you have a better chance of getting it right. So y equals, let's see, 28 over 5. Box your answers, and you are set. Again, the key is you want to write that out. Now, there are two more really ugly triangles that will never go away. So you need to know how to deal with them. And again, the first step is going to be to redraw them so that you can see what you're talking about. The first is this one. It will appear in just about every problem set for the rest of your pre-calculus career. So if you learn it now, you're set. If you don't pay attention to me, then I'm going to send you back to watch lesson 3 when you're probably at lesson 100. Okay, so we have this angle, angle 1. We have 6, 4, A, B, C, and 4. Okay, are there similar triangles here? Absolutely. Is it blatantly obvious right now? Absolutely not. So I'm going to use some colors. There's a small triangle here. If I redraw that triangle, I have a right angle, I have angle 1, I have 6, 4, and A. Happy campers? Well, let's redraw the big triangle. So that's going to be this one. Again, I'm drawing them so that they point in the same direction with the angles pointing in the same direction. So, since the big triangle has angle 1, that's still there. The big triangle has the right angle. And so they are similar triangles because they have 2 angles in common, which means they have the third angle in common. Now, what do I put on the bottom here? A lot of students will put 4. That's wrong. If you look at this picture, the base is 6 plus 4, which is 10. Over here, we have C, and over here, unfortunately, we have A plus B. Ugly? Yeah. Yeah, it is. That's okay. You're in pre-calc. You can deal with it. You got this. On a scale of 1 to you having this, solid 9.5. Sorry, that was me. All right, moving on. So here, what are we thinking? Well, we have a right triangle. The lesson was on Pythagorean theorem way back at the beginning of the lesson, like 15 minutes ago. So I'm going to do a squared plus b squared equals c squared. I'll write my equation because Belanda goes crazy if I don't. A is 6. I know that's confusing because you have another a. That's okay. A squared. See, I already messed up. 6 squared is 36. 4 squared is 16. So that's 36, 16, 42, 52. So a is the square root of 52. Are we happy with that? No, that's ugly. But maybe I can pull out 2 there. 2 square root of 13. There we go. Okay, so that's A. So in my drawing, since I've redrawn it, 2 square root of 13. And I know that this one is now 2 square root of 13. Can I find C? That's the next one I would do because I can't really find B right now. And if I am, I'm doing similar triangles with 2 square root of 13s everywhere. That's gross. So I'm going to find C. I find the pair that matches. So 6 over 10 equals 4 over C. Cross multiplying, I get 40 over 6, which is 20 over 3. Is that correct? Yes, it is. So that's 20 over 3. Now we are at an impasse. We can either do the Pythagorean theorem with ugly numbers, or we can do similar triangles. I choose similar triangles. Because I'm out of space, I'm going to remove this. Sorry. that one board life. Once we get our next board installed, I could keep going, but not now. So I'm going to do similar triangles. So 2 square root of 13 over, now this is tricky, 2 square root of 13 plus b equals 6 over 10. Okay, now we're going to cross multiply. So I have 20 square root of 13 equals 12 square root of 13 plus 6b. So I'm solving for b. I'm going to move everything to the other side. 20 minus 12 is 8. Divided by 6 is 4/3 square root of 13 equals b. That wasn't too painful. Okay? And that's similar triangles. Now, if you thought that triangle was hard, yeah, we're not done yet. I'm sorry. We have one more that you need to know. And I'm going to show you how to set it up, and then you can solve from there. And that is this triangle. We actually use this triangle later on to prove the Pythagorean theorem. So that's pretty cool. This is a right triangle, and it has 2 triangles inside of it. Woo! And they want us to find a whole lot of things. They want us to find, oh, this is, oh dear. A, 4, H, B, 8. How many triangles do you see? It's like those exercises that they used to do in the magazines when you're a kid. There are 3 triangles here. There's the big triangle, there's the triangle to the left, and there's the triangle to the right. So I'm going to write them all out in terms of the triangle on the left. It has a right angle, has angle 1, and this is A, H, and 4. Now, let's draw the big triangle. Again, I'm going to draw it this way though, pointing this way. So I know that I want the right angle there. I want angle 1 here. Now, you'd be surprised to find out that the big triangle and this triangle are similar. Why? Well, because they both have angle 1, they both have a right angle, and they both have angle 2, but we'll get to that later. So, what's the side between angle 1 and the right angle? Angle 1 and the right angle is now A. In a different spot. Isn't that strange? That's really strange. Now, between A, or the right angle, and this unknown angle over here is B. And the hypotenuse of the big triangle is 12. What is this unknown angle? Well, it's angle 3, or angle 2 in the big triangle, which means that it's also angle 2 in this one. If a triangle has 2 angles the same, the third one must also be the same. All right, let's do the last triangle. I know that's a little tricky. If you need to pause and go back, between angle 1 and the right angle, and the big triangle is this side. Between the right angle and angle 2 is this side, right? Right angle, angle 2 is B. And then the hypotenuse between 1 and 2 is 12 for the big triangle. Now for this right triangle over here, I know that I've drawn all over it, so it's quite confusing at this point. You can also check your book. They have these beautifully drawn out. But again, we want them to point the same direction. Between angle 2 and the right angle, for this one is 8. Between the right angle and angle 1, which is our mysterious angle, this is angle 1, this is angle 2. Strange, I know. Between the right angle and angle 1 is H, and the hypotenuse of this triangle is B. Whew! Now, how do we actually solve this? There's a trick. Okay? And the trick is this. If you want to solve for A, you pick the 2 triangles that have A in them. They've given you enough information to solve. So let's pick these 2 triangles. A over 12 equals 4 over A. Are we scared that we get A squared equals 48? No, we'll just take the square root. 48 is 16 times 3, so we'll call this 4 square root of 3. Do we care about the negative one? No, because measurements are not going to be negative. Is that correct? Yes. All right, now if I'm solving for B, I'm going to pick the 2 triangles that have B in them. So B over 8 equals 12 over B. Again, I have B squared equals 72 I'm going to take the square root of both sides. 72 is 9 times 8. So this looks like 36 times 2, so 6 square root of 2. There we go. Whew, mental math. It's hard. I did that wrong. 8 times 12 is not 72. 96. So b is 4 square root of 6. And then to find h, you're going to use these two. So it would be h over 8 is 4 over h. I've run out of space and time, so that, my friends, is a very long problem set number 3.